I don't know if yours, I finally got the paper motor apart. Look how I did the windings. That's good. Everything about paper motors was so unique too, I read. They had their own design to make them last the longest possible out of every motor this country made at the time. All this part here is the actual part. This whole sleeve is part of the inner raceway of that bearing. The SKF, Swedish made bearings, the front one's the same. This outer sleeve here is all part of the inner raceway of this bearing. It's all one piece. Yeah, you can't actually buy those bearings anymore. They're a special bearing. They're not ordinary ball bearings, so I can't just replace them with modern ones. Well, I could, but this sleeve will have no seal on this shaft. It's part of what centralises it, so I'll wash this out and got new grease packed in it, which is still half good, the original one that is, but it's still noisy. It's got a bit of play in it too, this bearing. To get the fan off, I've had to loosen it, put a screwdriver behind it, between the back half of that fan, and tightly wedge it in and wedge a flat blade between this and this little tiny gap here. Just twist it carefully, had it soaking in CRC for a bit, till it freed up. So I couldn't get it past this point. It's all mushroomed here, so I've had to run the motor on the VFD, holding the fan, and let it spin like a bad bearing. Let it spin and spin and spin and spin while holding the fan while the shaft was still spinning, and pull the fan forward so it spin on here, wouldn't move. So I ran a file along here while the motor was spinning, ran this across a file and folded it down like a lathe. I turned it down a bit for the fan to come off. But unfortunately someone's had to go with this sometime in the past. Quite a long time ago, because I've chipped this bloody bit of the plate off and stripped the end of this stud. Well, this stud's replaceable, that's easy enough. I can either drill out these two sides or this plate, but that's cast iron. This isn't going to be easy to drill without breaking it. If I could drill those two out and turn it so it's got a nice even clamp again. I'll put the original washer they had back on there. They had a washer on it. So they've actually had attempted to replace this bearing in the past, but knowing that this bearing is not available anymore. You can't get these bearings anymore. Sort of put it back together and just, yeah, pack new grease in it and put it back together. It's had a bit of bloody water in it. It's been outside for a while. You see how it's been sitting underwater? Up to about here with water. Because this was open when it was sitting in sitting behind the shed. Sitting out in the middle, and this was all open here. This filled up with water. I got in through there and filled up to here with water. It's long gone now, but I'll have to clean all this out. Very well made motor. I've just carefully secured the windings in this tape. Actually no, it was sitting on its side. Oh, that's sort of, it was on its side, this was facing up. And this was on tightly too, so with the conduit that was sticking out of it was open. The water must have got in through the conduit. You can see this was sitting on its side and the water sat here for a long time. She got full of water. Alright, let's get the vacuum cleaner out and clean this thing out. Alright, that's quite a nicely made motor. The windings still look brand new. The plugs, they're actually brass plugs, look that rubber. Oh, I see water goes in there and it goes out the side. There's a hole on the side of that plug. That one's a brass one, so water goes in there, it goes out the side. Interesting. Very good design. Quite good motors these are. Apart from a chipped foot off the other side, but anyway. If I could find more, these would be nice, because I could just use them for parts. Should I come across any that are burnt out, that is. Because it's good to keep them for parts even. But anyway. These motors usually last forever. This has also got wood in there too to pack the windings in. Some more newer than the McCall one, because it's got the modern shaped stator that don't go, they just go straight. And here it's curved instead. As you see with the McCall one, the windings are in this pattern, this chevron pattern. This is a more modern rotor, the chevron pattern's inside the rotor. And the older McCall one didn't have that, the rotor just looked like it was solid. Bit dirty in there, but I'm sure it'll clean out alright. But yeah, love to find more of these. that have in good working order. Many of them actually still are today. I've seen heaps of machinery with these old pipe motors and I'm still going strong. Need some bloody compressed air. That'd be nice, right? The air compressor to blow all this out. Should clean up alright there. I'll get another brush and I keep scrubbing to get all the loose bits off and we should be done. Alright, put them back together. Yeah, these bearings are not something you can buy anymore. This actual sleeve here is actual part of the bearing in a raceway, not part of the shaft. I thought the shaft was actually stepped. It was machined like that, but it's not. That's actually the inner raceway of the bearing itself, so nothing I've seen before actually. They're actually unique bearings to this motor. These are actually quite well made motors, these old popes. Nowadays Simpson makes some of the shittest stuff on the market. So yeah, Australia's just bloody lost it. Went from making some of the best stuff in the world to the importing the absolute lowest quality stuff from the bowels of China. Oh, it hurts. Step it down. A bit quieter. Alright, I'm going to get the multimeter and carefully go on between this shaft and the ground and see if I get any currents or voltages. That's what I forgot to do that with my coal motor, a little experiment there. So I got a bit of crappy brush, I'm making a bit of copper wire or something so I don't damage the plug in the multimeter. Run it across here, the smooth part, or here somewhere, and get a good connection between there and ground and see if I get any voltages or anything. Get the frequency catch up with the rotor. AC volt setting. See what we're getting any. 1.3 volts being induced into the rotor. Don't short that out. 1.3 volts in the rotor. There you are, I've got 1.3 volts being induced into that rotor. There's a crappy bit of wire. Don't ruin your multimeter or the multimeter leads on these things. A bit of wire is a good idea. Make yourself a brush set up, and that's it. 1.2 volts AC going inducting into the shaft. Now I'll see if I get a current measurement there. There shouldn't be much current, so shouldn't be. I got amps. They're milliamps. I just realised I got a microamp setting on this thing. Hang on a minute, I'm after I use 2 rounds here. I keep forgetting the bloody tripod. Alright, let's try milliamp range. Oh yeah, that's right, DC, you've got to get range here. AC, there we go, now I'll try it. Nothing. Alright, microamp range. AC, always select AC. Not going to be DC. Interesting. I've got nothing on the microamps range. Well, that's odd. Oh, wait a minute. So, there we go. Common for the amp as well. Now we'll try it. Back in milliamps range. So to AC again. Now we'll try it. Nothing, alright, back on the microamps range. Nothing. Range. No decimal point, see that does nothing. Nothing going on there, no currents. Interesting, I got voltage but no current. Bit of friction in the bearings though. I did put a lot of grease in that. Shaft's not getting hot. Yeah, the shaft's not getting hot in this motor. I should have got my little blue CMG one. I got the little tiny blue CMG motor. I should have grabbed that one here, because that one here gets hot in the shaft. That one here will give me a reading. This one doesn't heat the shaft up. Yeah, the fan's nice and loose now. I've got the key laying there properly though, so because everything's all been loosened up now. Yeah, I put nice and fully re-greased both the bearings in this. That turns much better. Anyway, I've got no currents going to the shaft or into the rotor. I just got about 1 volt AC going between the shaft and the ground. No current, so there is something being inducted, but it's not very much. So it shouldn't do damage. Anyway, that'll be enough for now. Thanks for watching.